Hey everyone, welcome to Future Forward. I'm Alex, joined as always by my incredibly curious co-host Rowan.
Hey there, I'm already excited about today's topic, and today we're diving into what might be the most significant technological leap humanity has ever faced.
And I have to say, I'm both excited and slightly nervous about this one. We're talking about AGI, artificial general intelligence, the kind of AI that could actually think like us, right?
Exactly. And here's what fascinates me. Some of the biggest names in tech, like Sam Altman from OpenAI, are saying we might achieve AGI as soon as this year or next. But other experts are saying we're decades away.
Wait, that's a pretty massive difference in predictions. How can experts be so far apart on this?
That's exactly what makes this topic so compelling. We're watching this incredible race unfold from the early dreams of the 1950s to today's cutting-edge breakthroughs. And the stakes, well, they couldn't be higher.
I've heard people call it the last invention humanity will ever need to make. That's quite something to think about.
It really is. Today we're going to explore how we got here, where we're heading, and what it could mean for all of us. From the tech itself to the heated debates about safety and ethics to some truly surprising discoveries about how these systems are already developing.
I can't wait to dig into this one.
Let me take you back to where this fascinating journey really began. The 1950s were an incredible time of optimism in computer science. Scientists genuinely believed they could create thinking machines within a decade.
The 1950s? That's way earlier than I would have guessed. What made them so confident?
They had just developed the first electronic computers, and the possibilities seemed endless. These early pioneers, like John McCarthy and Marvin Minsky, thought if they could just program enough rules and logic into computers, they'd eventually create human-like intelligence.
That sounds a bit simplistic now, doesn't it?
It really does. But you have to understand they were working with what they knew at the time. They created what we now call symbolic AI, basically trying to represent the world through logical symbols and rules.
And I'm guessing that didn't quite work out as planned?
Not exactly. They hit what we call the AI winter in the 1970s when they realized just how complex human intelligence really is. You can't just program common sense, or creativity, or intuition.
So what changed? Because we're obviously in a very different place now.
The real breakthrough came with the shift from rules to statistics. Instead of trying to program every possible scenario, researchers started creating systems that could learn from data. And that's when things got really interesting.
Oh, right. Is this where neural networks come in?
Exactly. Though neural networks were actually conceived back in the 1940s, they didn't become practical until we had enough computing power and data to make them work. The real game changer was something called deep learning.
I've heard that term thrown around a lot, but I'm not sure I fully understand what makes it so special.
Think of it this way. Earlier AI systems were like trying to teach someone by giving them a huge rulebook. Deep learning is more like showing a child thousands of examples and letting them figure out the patterns themselves.
That's actually a really helpful way to think about it. But what made researchers shift from one approach to the other?
A few things. First, computing power grew exponentially, but more importantly, we started to understand better how human intelligence actually works. We realized we don't think in rules, we think in patterns and associations.
And that's how modern AI systems work?
Precisely. The transformer architecture, which powers most of today's advanced AI systems, is actually inspired by how our brains process information, though in a very simplified way.
Wait, so we're using what we learned about human brains to build artificial ones?
Yes and no. We're taking inspiration from biology, but we're not exactly copying it. It's more like how early aircraft designers were inspired by birds, but modern planes don't flap their wings.
That's fascinating. So where does this leave us now? Are we closer to the optimism of the 1950s or the skepticism of the AI winter?
Well, we're in a really unique moment. We've made more progress in the last 5 years than in the previous 50. But we're also much more aware of how complex the challenge really is.
And I'm guessing that's why we're seeing such different predictions about when we'll achieve AGI?
Exactly. Some experts see our recent breakthroughs as signs we're on the verge of something revolutionary. Others look at the same progress and see how far we still have to go in areas like common sense reasoning and general problem solving.
It's kind of humbling when you think about it, how something that seemed so straightforward in the 1950s turned out to be such an incredible challenge.
And that's what makes this field so fascinating. Every answer we find leads to new questions and new possibilities. Speaking of new possibilities, there's something fascinating happening right now in how we're actually building these systems. The architecture of modern AI is taking some surprising turns.
When you say architecture, you mean how these systems are actually built, right? The nuts and bolts of it all?
Exactly. And what's really interesting is we're seeing multiple approaches developing simultaneously. It's not just one path to AGI, we're exploring several different routes.
Like what?
Well, one of the most intriguing approaches is what we call multimodal AI systems. These are systems that can process and understand different types of information: text, images, sound, even physical movements, all at once.
Kind of like how humans can watch a movie, follow the plot, and understand the emotions all at the same time?
That's a great analogy. And what's particularly exciting is that these systems are starting to show what we call emergent behaviors, abilities we didn't explicitly program into them.
That sounds both amazing and slightly concerning. What kind of behaviors are we talking about?
Well, for instance, some large language models have shown they can solve complex mathematical problems using methods their creators never taught them. They're finding novel ways to approach problems, sometimes even surprising the researchers who built them.
So that they're actually learning to think for themselves in a way?
It's more like they're finding patterns we didn't even know were there. Another fascinating development is in something called zero-shot learning, where AI systems can handle tasks they were never explicitly trained for.
That sounds almost impossible. How can they do something they weren't trained to do?
Think about it like this. Humans can often figure out how to use a new tool just by looking at it, even if we've never seen that specific tool before. We apply our general knowledge to new situations.
And AI systems are starting to do that too?
Yes, and it's leading to some interesting debates about whether we should be trying to replicate human cognition at all, or if we should be exploring completely different paths to intelligence.
What do you mean by different paths?
Some researchers are advocating for what they call life-inspired approaches. Instead of trying to copy human brains, they're looking at how intelligence emerges in other biological systems, everything from ant colonies to fungal networks.
That's fascinating. So we might end up with an artificial intelligence that thinks in a completely different way than we do?
Yes, and this ties into one of the biggest challenges we're facing. How do we create systems that can transfer knowledge between different domains? It's something humans do naturally, but it's incredibly complex to replicate artificially.
I guess that's what makes it general intelligence rather than just really good specialized AI?
Precisely. The current systems we have are incredibly powerful at specific tasks, but they lack that human ability to adapt and apply knowledge flexibly across different situations.
So what's the most promising approach right now? Is there one that seems to be pulling ahead?
The interesting thing is that some of the most significant breakthroughs are coming from combining different approaches. We're seeing hybrid systems that use both symbolic reasoning and neural networks, for instance.
Like getting the best of both worlds?
Yes, and what's particularly exciting is how these different components can complement each other. The neural networks handle pattern recognition and learning, while the symbolic systems provide a framework for logical reasoning.
It almost sounds like we're building different parts of a brain and trying to get them to work together.
That's a good way to think about it. And just like with the human brain, we're discovering that the whole can be greater than the sum of its parts. These systems are showing capabilities that emerge from the interaction between different components.
And I'm guessing that's where some of those unexpected behaviors come from?
Yes, it's in these interactions that we're seeing some of the most promising signs of what might eventually lead to true artificial general intelligence. You know what fascinates me most about the AGI landscape right now? The incredible divide between what I call the sprinters and the marathoners in the field.
Oh, that's an interesting way to put it. I'm guessing the sprinters are the ones saying AGI is just around the corner?
Exactly. Take Sam Altman from OpenAI, for instance. He suggested we might see AGI as soon as this year or next. And he's not alone. There's a whole group of researchers and tech leaders who believe we're on the verge of a breakthrough.
But I'm sensing there's another side to this story.
The marathoners, yes, they're looking at the same technology, the same breakthroughs, but drawing very different conclusions. They're saying we need to think in terms of decades, not years.
What's driving such different perspectives? I mean, these are all brilliant people looking at the same evidence, right?
That's what makes this debate so fascinating. It's not just about technical disagreements, it's about fundamentally different philosophies about what intelligence actually is.
Can you break that down a bit?
Well, the optimists often point to the rapid progress we're seeing in things like large language models and multimodal systems. They see these capabilities scaling up and believe we'll reach human-level intelligence through sheer computational power.
While the cautionary voices think there's something more fundamental we're missing?
Precisely. They argue that we still don't understand core aspects of intelligence like consciousness, common sense reasoning, or genuine understanding. They worry we're mistaking sophisticated pattern matching for true intelligence.
I've heard some researchers actually raising alarm bells about moving too fast, that we might be creating something we can't control.
And that's where this debate gets really interesting. The cautionary voices aren't just concerned about technical limitations, They're worried about safety protocols and ethical considerations.
Like what specifically?
Think about it this way. If you're building something that might eventually become smarter than humans, don't you want to be absolutely certain you've got the safety mechanisms right? The cautionary researchers argue we need to solve what's called the alignment problem first.
The alignment problem? That's about making sure AI systems actually do what we want them to do, right?
Yes, and making sure they maintain those goals even as they become more capable. It's not just about programming rules. It's about ensuring the system's fundamental objectives align with human values.
That sounds incredibly complex. I can see why some researchers are advocating for a slower approach.
And here's where it gets even more interesting. Some researchers are suggesting we need to completely rethink our approach to AGI development. They're advocating for what they call transparent AI, systems where we can actually understand how they're making decisions.
As opposed to the black box nature of current AI systems?
Right. The current deep learning systems are incredibly powerful, but even their creators often can't explain exactly how they arrive at their conclusions. That's making some researchers very nervous about scaling these systems up to AGI level.
So we've got one group saying full speed ahead, and another saying we need to slow down and rethink our entire approach.
And everything in between. There are researchers proposing hybrid approaches, suggesting we need both rapid development and careful safety considerations. They're trying to find a middle ground.
It almost sounds like we're in a global experiment that nobody quite knows the outcome of.
That's actually a perfect way to put it. And what makes it even more complex is that this isn't just happening in one lab or one company. We've got multiple teams around the world, all working with different approaches and different philosophical foundations.
And I'm guessing they're all influencing each other's work.
Absolutely. Ideas are being shared, debated, refined. It's like watching evolution happen in real time, but with ideas instead of organisms. And just like evolution, it's impossible to predict exactly where it's going to lead. You know what's really fascinating about the current state of AGI research? We might be thinking too narrowly by trying to recreate human-style intelligence. There's this whole other world of possibilities we're just beginning to explore.
What do you mean? Isn't the goal to create something that thinks like we do?
That's what everyone assumed at first, but some researchers are suggesting that might be limiting our perspective. They're looking at intelligence in nature that works completely differently from human cognition.
Like what? I'm really curious about this.
Well, take slime molds, for instance. They can solve complex optimization problems without anything we'd recognize as a brain. They create incredibly efficient networks for finding food that sometimes outperform human-engineered solutions.
Wait, are you saying we're getting AI inspiration from slime?
In some cases, yes. And it gets even more interesting. Some researchers are studying how ant colonies make decisions as a collective intelligence. No individual ant is particularly smart, but together they solve complex problems.
So, we might be able to create intelligence that's distributed somehow, rather than centralized like our brains?
Exactly. And this is leading to some fascinating new architectures for AI systems. Instead of trying to build one massive system that does everything, some teams are experimenting with swarm intelligence approaches.
But wouldn't that be more like specialized AI rather than general intelligence?
That's where it gets really interesting. These systems are showing signs of emergent properties, capabilities that arise from the interaction between simpler parts. It's not unlike how consciousness might emerge from the interactions of neurons in our brains.
You're blowing my mind a bit here. So we might end up with AGI that thinks in a completely alien way to us?
Potentially. And some researchers argue that might actually be safer. If we create intelligence that thinks fundamentally differently from us, it might be less likely to compete with us or misunderstand our intentions.
I never thought about it that way. But how would we communicate with something that thinks so differently?
That's one of the big challenges researchers are grappling with. They're looking at things like fungal networks, which communicate through chemical signals, for inspiration about alternative forms of information exchange.
Nature really seems to be the go-to source for new ideas here.
It makes sense when you think about it. Nature has had billions of years to experiment with different forms of intelligence and problem solving. We're just beginning to understand how diverse those solutions can be.
But surely there must be some common principles that define intelligence, regardless of how it manifests.
That's actually a huge debate in the field right now. Some researchers argue that adaptation and learning are the key markers of intelligence, regardless of how they're implemented. Others focus on the ability to create and manipulate abstract models of the world.
And I'm guessing different approaches might be better suited for different aspects of intelligence?
Precisely. We might end up with a spectrum of artificial intelligences, each drawing inspiration from different natural systems. Some might process information more like plants, others like insect colonies, and others in ways we haven't even imagined yet.
That's fascinating and slightly mind-bending. Are there any working examples of these alternative approaches?
We're seeing some early success with what are called morphological computation systems. These are systems where the physical structure itself does part of the computing. It's similar to how the shape of a bird's wing contributes to its flight control without needing complex brain calculations.
So the hardware and software aren't as separate as in traditional computers?
Exactly. And this might be a crucial insight for AGI development. Instead of trying to create intelligence that runs on traditional computer hardware, we might need to rethink the entire physical architecture of these systems.
It sounds like we're not just reimagining artificial intelligence, we're reimagining intelligence itself.
That's beautifully put, and it might be exactly what we need to do to make the next big breakthrough in AGI development. You know what keeps me up at night, Alex? Not just the technical challenges of AGI, but how it might reshape every aspect of our society. We're potentially looking at the biggest transformation in human history.
That's quite a statement. Are we talking beyond just job displacement and economic changes?
So much beyond that. While everyone's focused on whether AGI will take their job, we're actually facing much deeper questions about what it means to be human in a world where machines can think.
Like how we might define consciousness and intelligence when we're not the only ones who have it?
Exactly. Philosophers have debated consciousness for centuries, but imagine when we have to legally decide whether an AGI system is conscious.
I hadn't even thought about the legal implications. That's going to be incredibly complex.
And here's something fascinating. Some economists are suggesting we might need to completely reimagine our economic systems. Our current models are all based on human labor and human decision-making.
But if AGI can do most jobs better than humans, what happens then?
That's the trillion-dollar question. Some experts are proposing what they call abundance economics, where AGI and automation create such efficiency that we need to rethink the very concept of scarcity.
That sounds almost utopian. But I'm guessing there are potential downsides too?
Absolutely. We're looking at massive shifts in power dynamics. The organizations or nations that first develop AGI might gain unprecedented advantages. It's why some researchers are advocating for international cooperation rather than competition.
Like a global approach to AGI development?
Yes, but it goes beyond just development. We need global frameworks for managing AGI deployment, ensuring equal access to its benefits, preventing monopolies. It's incredibly complex.
And I'm guessing we need to figure this out before AGI arrives, not after?
Precisely. But here's what really fascinates me. We're seeing early signs of how society might adapt. Some universities are already creating new fields of study, combining technology, ethics, and social science, specifically focused on AGI integration.
So we're actually preparing for this future already?
In some ways, yes, but maybe not fast enough. Think about how social media transformed society in just a decade. AGI could cause even more dramatic changes in a shorter time frame.
That's actually quite scary when you put it that way.
But there's hope too. Some cultural anthropologists are studying how different societies might adapt to AGI based on their existing values and beliefs. It's not one size fits all.
So different cultures might integrate AGI in different ways?
Yes, some might embrace it fully, others might restrict it to specific domains. We're already seeing this with current AI. Different countries have very different approaches to regulation and deployment.
It's almost like we're preparing for first contact with an alien intelligence, except we're creating it ourselves.
That's a fascinating parallel. And just like in those scenarios, we need to think carefully about maintaining our human identity and values while adapting to this new reality.
How do we even begin to prepare for something this big?
Well, some forward-thinking communities are already experimenting with AGI governance models, creating frameworks for how humans and AGI systems might cooperate rather than compete.
Are people actually optimistic about this future, or is everyone just worried?
It's a real mix. Some see AGI as humanity's chance to solve our biggest challenges: climate change, disease, poverty. Others worry we might be creating something that could fundamentally change what it means to be human.
I suppose the truth might end up somewhere in between.
That's often how these transformative technologies play out. The printing press didn't destroy society as some feared, but it certainly changed it forever. AGI might be similar, just on a much larger scale. You know what strikes me most after exploring AGI today? We're not just watching a new technology develop, we're watching humanity grapple with perhaps its greatest intellectual achievement.
And possibly its biggest challenge. The range of possibilities we've discussed today is just mind-expanding.
What fascinates me is how we're seeing this convergence of different approaches. From neural networks to swarm intelligence, From biological inspiration to completely novel architectures, we're not just trying to recreate human intelligence, we're reimagining intelligence itself.
And the timeline predictions are so varied. Some saying next year, others saying decades away. It's hard to know what to think.
I think that uncertainty is actually valuable. It keeps us both ambitious and cautious. We need that balance between pushing boundaries and ensuring we develop AGI safely and ethically.
You know what really stays with me? The idea that AGI might think in ways completely different from human intelligence. That's both exciting and slightly unnerving.
Exactly, and that's why the decisions we make now are so crucial. We're not just developing a new technology, we're potentially creating new forms of intelligence that could exist alongside humanity for generations to come.
So, where do you think we go from here?
I think we need to embrace both the excitement and the responsibility. We're standing at a unique moment in human history where we might create something that fundamentally changes what it means to be intelligent, to be conscious, to be human.
That's quite a thought to end on.
And that's exactly why we need to keep having these conversations. The future of intelligence itself might depend on it.